Hey guys, good morning. Welcome to the Fundamentals of Aerospace Design lecture series. Today we are going to see the topic on aircraft power plant. This is Professor Nehru, Department of Aerospace Engineering, SNS College of Technology. In last few classes, we are seeing the different instruments which are used in the aircraft and the indicators which are used in the aircraft. And now we are going to see the power plant. An aircraft power plant is essential that engine and its related system that provides the necessary power for operation of the aircraft. Here are some basic idea about the different types of power plant. One is piston engine, turboprop engine, turbo shaft engine, jet engine, and rocket engine. So the principle of the aircraft power plant, one is thermodynamics, combustion, and propulsion. Coming to the thermodynamics, the study of heat and energy conservation, the fundamentals to understanding this how engine produce power. Combustion, the chemical process of burning fuel to releasing energy, and propulsion, the mechanism by which an aircraft is moved forward and achieving through the thrust generation. Understanding this basic idea about the aircraft power plant provides the foundation of further study in the aerospace engineering. First one is the power plant. Power plant introduction. We'll see this picture. Engine is there, firewall is there, and the engine cowling is there, and the propeller is there. This is uh, the piston engine. So piston engine, also known as reciprocating engine, operates similar to a car engine. They use one or more piston to convert pressure into a rotating motion. The major components of the piston engine are cylinder, piston, crankshaft, and propeller. Cylinder where the fuel combustion occurs, piston moves up and down within the cylinder, crankshaft that convert the piston linear motion into the rotational motion, propeller which attach to the crankshaft to produce thrust. The various types of piston engines are inline engine, cylinder arranged in the single row, V-type engine, cylinder arranged in the two rows in V shape, radial engine, cylinder arranged in a circular rotation around the crankshaft. The major application of this piston engine used in the small aircraft and the older models. Next, coming to the turboprop engine, a combined features of both turbine and the propeller engine, using a turbine engine to drive the propeller. Components of the turboprop engine: gas generator, propeller, reduction gearbox. Gas generator, it is compressor, includes compressor, combustion chamber, and the turbine. Propeller driven by the turbines. So reduction gear helps to reduce rotational speed of the turbine to speeds suitable for the propeller. The application of this turboprop engine used in the medium-sized aircraft that required good fuel efficiency and ability to operate for short runway. Next one is turbo shaft engine, similar to the turboprop engine, but designed primarily to drive a shaft rather than the propeller. The major components: gas generator, free power turbine. The gas generator same as the turboprop engine, whereas driving free power output shaft without being directly connected to the gas generator. The application of this turboshaft engine commonly used in the helicopter and the other application requires shaft power. Coming to the turbojet engine, the operation: air gets intake at the inlet, compressor get compress the air and combustion chamber to take the air combustion will take place. Turbine produces the energy and rotate the compressor via the shaft, and exhaust the entire the combusted fuel or exhaust as the nozzle, which produces the thrust force according to Newton's third law. Next one, turbo fan engine. The basic operation is intake. Air is drawn into the engine, the large in front of the mounted fan. Fan divider drives the air into two streams. a bypass stream that flow around the core of the engine and core stream that enter into the core engine. Compressor core stream is compressed by axial compressor, increasing the pressure and the temperature. Combustion chamber compressor are mixed with fuel in the combustion chamber and ignited, generating high temperature and high pressure gases. Turbine, the hot gases expanded through a series of turbine which extract energy to drive the fan and the compressor. The turbine is connected to the fan and the compressor via the shaft. Exhaust, the gas are expelled throughout the nozzle, creating thrust. The bypass air which flow around the air core, combining with the exhaust gas to produce additional thrust. So in terms of bypass ratio, the ratio of the mass of a air bypass, the general engine core to the mass of the air pressure throughout the core. High bypass turbos are common in the commercial aviation for air efficiency. If the bypass ratio is high, the efficiency is high. Thrust and efficiency, turbofans are designed to provide high thrust while being a more fuel efficient than turbojets, especially at lower speed and altitude. Coming to the rocket engine, produce thrust by expelling high speed exhaust gas from the combustion process. Types, we have liquid rocket engine, components, solid rocket engine, hybrid engine. Both fuel and oxidizer are getting and combustion chamber and nozzles are there in the component. Solid propellant are pre-mixed and packed in the casing. This component casing, solid propellant nozzles are there, where the application is used in space exploration and military missiles. Thank you. We'll see in the next class.